Hello everybody, hi guys. Today I'm going to show you how this example works. This is a multiplayer framework for Unity. It uses Socket, WebSocket, actually Socket IO. It works on WebGL. Here I'm switching between the Unity editor and a build in WebGL. I'm currently running locally. It does things like the example has a character creation menu that you can see here in a second, and it's meant to simplify some of the some function, allow you to quickly prototype things in a multiplayer. So I create my character, like there are two examples in this project, but this one is kind of like a first person controller that already has a character that is rigged and everything. And it already takes care of things like creating objects, and these objects are online. I have another object here, and the physics should be more or less pretty much consistent between clients. This uses smart clients, meaning the most of the operations are done on the client side, and the server side is actually pretty agnostic. The server just takes care of receiving controls, receiving events from the clients, and sending them back. So there is almost no logic, no game logic stored on the server side, which is Node.js. And most of the stuff is actually happening on the Unity side. So this setup is a little tricky, so that's why I'm making this video to help you set it up and test it. So first, the project is split in two parts, in two repositories that you can find on GitHub: the server side and the client side. The server side is a Node.js. It is mostly one file, really, server here. You can clone this repository, save it somewhere in your hard drive, and then open it. My recommendation is to use Visual Studio Code to manipulate the code on the server side, and Visual Studio to manipulate the code to be programmed on the client side. I find this sort of like separation between client and server particularly useful because now we are using two different languages, two different environments. So we are not just in the realm of JavaScript. So I have two editors, as you can see. One is the Visual Studio Code, which works very well for JavaScript and everything related to the internet, to the web, and Visual Studio, that's the more like a complete version that plays very well with Unity. Has all the code completion for Unity. So once you download the project file, let me see if I can find it. Once you download the project file, you can just launch it, open it in Visual Studio Code. You open a new terminal window if you don't have it. Let me close it. You open a new terminal window on the project root. You probably have to install the dependencies, so you do npm install and the usual stuff. The dependencies are mostly Express and Socket IO, maybe also .env, but anyway, just do npm install and it should install everything. And then you can start a project with node server.js or nodemon server.js. So if you're hitting this and you start a local server listening to the port 3000. So now your server is running locally. Let's see the other side, the client side. So this is another repository here, and it's a Unity repository. It is actually not a full Unity project. I decided to upload only the assets folder. I don't know if it's the best practice. It's just like a whole Unity project can be like many megabytes that you don't really use, that might be machine and system dependent. So this is just the assets folder. So you can just like straight up download this, maybe as a zip or whatever, and then you create from the Unity hub, you can create a new project and then import all of the content of that repository in the assets folder, which would be this one. So a Unity project is it's a bunch of things, library, logs, whatever. This is like a lot of stuff. So just go in the assets folder and just drop all the content on that repository in here, and I think it should work. So if your server is running and is running in listening to 3000 to the port 3000, you should be able to just hit play here on Unity, and something should show up, specifically the menu. You can type a username, select your character with two slider examples, and then the join button should be bright pink. If it's not, it's disabled. It means there's some issue connecting with the server. So maybe your server is not running, or you're not looking at the right port or address. But by default, if you just download it, it should just work. And then you click join, and you are in this empty world. By the way, the objects that I created before are still there. They are kind of persistent. They are both stored on a JSON file and also stored on the server if the server keeps running. By default, the server side also has a WebGL build of the project. So you can even check it by just doing localhost 3000, and that should should allow you to create a user and see the other users. So I'm kind of like working cross-platform now. I have one client in WebGL and one client in my Unity editor. They should exist in the same world. Like the reason I separated these two projects though, the client side and the server side, is because you don't want to upload your client project files. Unity has a separation between what the project file is, the source code essentially, and the stuff that gets published online, or the stuff that gets published in executable and distributed, right? You have to compile, you have to make a build. So this is the first main difference, moving to a JavaScript Node.js to a Unity kind of project. Unity has a separation between the project folder and the actual build. So every time you create a build, you will have to go to build settings, change your platform. You can make it standalone, an executable, or you can make it for WebGL, and then you publish it. So you're able to run another instance of your thing. That's kind of necessary if you want to test the multiplayer features, right? So a few things to set up. So most of the game logic here, the scene I'm looking, there are two scenes here in the scene folder. One is client and the other one is third person. The third person example, by the way, should work with the same server, logic. And it contains the same persistent objects, obviously. So it's a weird, multi-dimensional thing. But it's basically it actually works. If your game controller is configured properly, this is a twin stick sort of. I would say maybe overcooked, typical sort of character moving around and also turning around. This is not animated, it's a more simple example. It also doesn't have a menu. You don't have to use a character selection if you don't need to or if you don't care about it. So that's the third person scene, but I'm gonna just talk about the client scene, which is more or less the same. So you can see that there are two rather different gameplay, two different scenarios, but they work on the same server. The same server is running, and that's because most of the operations are done by the client, by Unity. So the server is just sends back and forth whatever it receives with a little bit of validation. There are some administration and username checks and things like that that you can explore on your own. Now, the game logic, I mean, there's not a lot of game logic, but the main thing you need to know to set up is this socket controller here. As you're opening it, it might be in, so it's in here in the hierarchy. You click on main. You should have a socket IO controller and a net manager. You can expand the controller and expand the settings and change your settings. So the settings for connections are usually three: the URL, the port connecting to, and the SSL. So this is the secure sort of web sockets or sockets. Yeah. So if you wanted to try this online, with other people, probably the easiest way is to publish it on, I would say, like on Glitch. Heroku is also pretty easy to use. It just has a couple of different settings. But anyway, if you were to publish it on Glitch, you will do something like this. You start your Glitch, you create a new project, and you import your project from GitHub. You can copy and paste the address of the server side. You want the servers obviously on Glitch. So you copy and paste that. You say OK. It will take a while to install the dependency and download the project. So we're gonna wait for it. Importing from GitHub. Be aware that Glitch is not, from my understanding, Glitch is not synchronized to the GitHub. So if you make a change to your repository, you will have to re-import it. It's a very quick way to import a full project, especially if you have assets or things like that. But it is not like a synchronization per se. So right now, being glitched, you should have a status OK. You can check the logs here. The logs is basically, yeah, I don't know what's going on here, but yeah. Oh yeah, I guess it's still maybe downloading stuff. Warning. Okay, well, we'll see. You should have okay, loading game state, listening to 3000. The logs is the same as the console here, the terminal here. So if it's listening to 3000, loading game state or whatever, it means that the server is running remotely. Yeah, and is a perfect copy of the repository. So what is the address? So if you're launching this particular project, you will the WebGL version will not work because the WebGL version, or maybe it will, or maybe it just does work. Okay, but it should not actually work because it's probably just listening to the local host. So the main thing that you need here, you're just using the server side, and you want to make sure that you give it, you will have a normal, like a URL here. Let's call it server server test. Oh, obviously I already taken server Unity. Yeah, server Unity, something like that. This is going to be your URL because Glitch provides a customized URL, serverunity.glitch.me. You see that there is the lock here, meaning that it uses an SSL sort of situation. So HTTPS, that means that it uses secure connection, and that's the same for the sockets as well. So that address is the address that you can put here in the settings in your client side. So settings, instead of looking for localhost, you can just copy and paste this thing here. My understanding is that Glitch doesn't like the port or takes care of the port, but definitely you need to enable the SSL. Let's see if the 3000 port works. Probably not. Okay, so set it to 0 and then launch it. All right, so you see that the join becomes pink, and it should say server message connecting to server message connected, players online 0. So there's no player online, but you are connected to the server. One of the reasons why I'm connecting to the server before I even join the game is because I want to be able to do some checks with names. So if I name myself Paolo, and Paolo is the name of an administrator, or there's already another user called Paolo, I can already do a check before my avatar is even in the game. So that is pretty much it for in terms of connecting globally. Now anybody who has this client and who points to server unity.glitch.me can play with me. We are networked. I can even now build a build, go to build settings and create a WebGL build, or a Mac or PC build, and all these clients will be all pointing to server.unity.glitch.me, and they will be all working together. They will be all networking together. So if I hit build, I will be creating something like that. There is also since you might end up alternating with localhost 3000. You might be alternating between testing things offline and online. Right now I'm just testing a thing offline, and I kind of have here a little override on the net manager script. Let's open it. So if you check the glitch boolean, the checkbox here, it's really nothing special. It just goes here and changes the settings. So you can add your domain here, server unity.glitch.me, for example, and then socket settings port 0. So these are like the settings for glitch. Heroku, as far as I know, uses the port 5000. So they are like slightly different settings. So if you don't have to change the settings here, they will be overridden if you click on glitch. It's just like a quick way to switch between online and offline. I find it useful because I use both. I'm not always online. All right, so yeah, that's pretty much it in terms of testing. There are a whole lot of errors that can potentially happen. A whole lot of like misconfiguration that can potentially happen. If you go to the distributed authority server README, you have a whole description of what this framework does, and then if you scroll all the way down, you can check the troubleshootings. Because there might be like some Unity compiling error. For example, if I start to build a WebGL build, and I hit build and the server is running, Unity will be like, oh, I cannot build a server because I cannot build a thing here in public because the files is being used or whatever. So you have to make sure that the server is turned off and it's not running when you're making the build. There are like a bunch of like finicky things like that. One problem might be related to the WebGL template. So if you go to project settings, you hit player, I already included two WebGL templates, which are the HTML page that contains your Unity applet or like your Unity objects when you're publishing for WebGL, which is online for browser use. So make sure that it's 2019 if you're using 2019, or 2020 if you're using 2020, and things like that. The default socket here, the template is basically including a link to the socket library on the client side. So it just does that because Unity by itself, it doesn't really ship and doesn't build for socket IO. This is a custom thing. All right, now I can talk a little bit about what the framework per se does and what are the main components. So there is this socket IO controller that should just like be a container for settings, and that works in the background and you don't have to care about it. Then there is this is like a part of an open source or semi-open source actually library and an asset that you can find in the asset store. The net manager Ideally, a net manager almost works like a black box. You don't really need to know a lot about the net manager, or you don't need to understand everything that is going on in here. But you know that here, if you like we did socket before, and you should know that I'm creating all the connections between events and function, essentially the handler functions that are listening to a certain event, for example, like connection or name error that are coming down from the server, and yeah, change owner and change type. Like some of these things are not necessarily like you don't necessarily have to know them. But a couple of important concepts are if you scroll all the way down, there are a bunch of data structures here, and that's because all the data, the kind of events that I'm receiving from the server or sending to the server needs to comply to certain classes. Unity is a strongly typed, C# is a strongly typed language, and it needs to know exactly what variables are being sent or packaged to communicate between clients and server. So it needs to know that, for example, this message data object is going to have an ID, which is a string, and a message. In this case, I guess the ID of the user that is sending this message and the message itself. There is a player data here, or an avatar data. So when I'm sending and receiving, say that a new avatar connects to the game from the client side, from my client, I need to know who this avatar is. So the server is sending me information about this avatar, and it will send me the ID, the socket ID, this new avatar. It will send me the nickname, and it will send me this DNA, which is kind of like an array of float that I just called DNA because it contains all the information related to the avatar. In this case, the DNA for this very minimal example is just the color of the avatar that you decide at the beginning, and a number that represents the head of your avatar. So you can change your head to make it, differentiate it. And obviously the server can, you can change the logic of the server to assign a different color automatically. Not all games should rely on character creation. Sometimes the server decides, has to make sure that all the characters are differentiable. I would say like Among Us, I think decides automatically the color, but you get to choose the hat or something like that. All right. Anyway, all the information in other words has to be serializable, meaning has to have has to be defined. You can see an example here when you when you want to emit a message, emit an event from a client, you usually do something like this. You create a new object in that data structure defined down below. Those are just classes. And this data structure will have an ID, which is my ID, and will have a message that is the new message. And then I'm using a JSON utility to convert this data structure into a string that can be sent up, through the WebSocket. So the WebSocket or the socket IO uses JSON, which is a JavaScript kind of conversion, kind of like a string version of a JavaScript object. And the JSON utility packages this C# object into JSON that becomes a kind of like a lingua franca kind of language that allows to communicate between the two. Conversely, when I'm receiving a message from the server, I have a handler or something like this on message, which is a handler that I define somewhere up there. So the on message will receive a socket IO event that I have to unpack. It will receive a JSON message, and I will have to use the JSON utility and do a from JSON, essentially create get the string and convert it to an object through this JSON utility. So my message data, like the data that I'm receiving from the server, will be in the message data format, and it will have a bunch of things. In this case, I'm not actually doing anything with this message, but say if this message was a chat message, I will type here something like, like some maybe speech bubble next to the player. So this is part of game logic, and that's why I don't have anything here. I'm also using the message data to send server messages like errors if your name is reserved or something. And server message here is just a debug log. So all the server messages will not be visualized to the player as in this super bare bone example, but they will be shown in the Unity console here. Let me see if I can even simulate one. Can be maybe if I try to yeah, but it's not that important actually. I think maybe the server is not okay. Oh yeah, so this server message unable to connect. The logic of the client already has a timeout, so that's because my server is not running, the local server is not running, so I need to run it, and I should be able to connect. I'm gonna restart the client just to be sure. So if your client doesn't connect, there might be a number of reasons in that case, because my server wasn't there, the local one. So if I try to join with no name, the server message will be you can't have a blank name. So you can even display here. This is really meant to be displayed on the interface. In this case, I didn't want to overload your scene. I wanted to maintain the scene as clean and minimal as possible. So you have just like a simple interface, which is 2 sliders and stuff like that. So in this example, let's go back to the main here. So in this example, I have a game menu script, which is handling basically this stuff, your nickname and the join and stuff. I already predisposed the framework to work without the game menu. So if you don't have any game menu, you can just remove it and it will enter the game without going through the join. So it will just automatically immediately join the server, or at least try to join the server. In this case, if you have a menu, it will just wait to create an avatar and things like that. In the net manager, at the very basic level, you have 2 fields for the my avatar prefab name and other avatar prefab name. To make things easier, since most games have some kind of avatar, maybe the avatar is not visible if it's like an RTS or something like that, but usually there is an object that contains the data about the player, right? When you're working in multiplayer, it's essential to differentiate your avatar, that is the one that responds to your control, and other people's avatar that might be kind of identical or might share a lot of things in common, because the other players still have like a collider or whatever, a character controller, a skin mesh renderer with like a fully rigged character and things like that. So they are very similar, but they don't have the interactive stuff. So the way I'm doing here, like the way I did it here, is basically by providing the prefab names. The net manager, every time a new avatar, a new user connects, will look into the resource folder, and we'll look at something called with that name. So avatar prefab, this is the prefab of your avatar. Other avatar prefab is the prefab of somebody else. And they are the same, basically the same thing. So this is where you have your armature and stuff, and it's in resources. If you never use resources, this is a special Unity folder that allows you to instantiate an object based like without referencing an avatar, without referencing a prefab. So basically, if something is contained in resources, you can read it by name because it's basically preloaded. Avatar prefab here is just whatever you want your avatar to be. It's got a bunch of scripts that I'm gonna just maybe talk about briefly. But then I created the other avatar prefab is essentially the same thing. You see that the icon is also a prefab icon, but it has a kind of like a grayed out side. That means that is a variation or a variant of your avatar. So, for example, if you have your avatar here and that's your own avatar, you can create a variant here by kind of like unchecking things here. And then if you're dragging, say that my avatar, other person avatar will not have a first person controller, will not have a first person interaction, but it will have an animator, and animator manager. It will have a collider because I want it to collide. I just want to remove the stuff that is related to, I don't know about the character controller, maybe. But the stuff that is related to basically user control, player control. And now I can sort of like drag and drop it here or in your, I'm not going to drag and drop it because I don't want to override it. But if you drag and drop it in your assets folder, Unity will tell you, hey, the thing that you created is kind of like, it's still a prefab, but you did something to it. So you can create a prefab variant. And that will be my situation here. That's the difference between my and the other avatar. So this is just a way to do it. That's to me, it was like the simplest way to do it, most straightforward. The advantage of that is that if I go to my main avatar in resources here, and I make a change to that, say that I change the head, or I completely, change my head variance here, then those changes will reflect on the variance. By the way, the logic here that I'm using is to have all the variant of the heads already in the character, and I just disabled the one that I don't want to use. In that way, I don't have to do like complicated instantiations, and in that way, I can visually position them, so I can just like change the positioning of each single head, making sure that they are where I want them to be visually. Anyway, so now I can get rid of this delete, and this avatar here, this is a menu avatar, so this is yet another variant that is just sitting there and has just that has no character controller. Is the one that you see here, kind of like just standing but animated. I want it to be animated, and I want to have exactly the same appearance of the avatar that will show in the game. All this stuff gets handled by the menu. So this avatar here will be deleted or disabled by the script that controls the menu here. So game menu, blah, blah, blah. So if you're creating your own avatar, you can just type your avatar prefab name. As long as it's in resources, you should immediately just load that. There's also spawn point here. The spawn point, that's a bit of a sticky issue because it's part of the net manager, because it's defined that the decided here, it kind of needs to be decided here by this package, but it really depends on the game logic. So where is the starting point when you are logging in? It depends on the game you're making. Spawn radius. In this case, I just have like all the avatars just are created automatically in around a certain point, and not exactly in the same point, because I don't want them to just like spawn on the top of each other, kind of like some Roblox game kind of do that. All right, so the game menu, consider that all the scripts are pretty well commented, so you can look it up what I'm doing here. I'm basically just connecting the slider to the appearance here. But speaking of appearance, my avatar here, like the avatar prefabs, which is similar to that one in resources, have an appearance script. And the appearance script is just converting that DNA stuff into the DNA list of float into the appearance, so I can change things like the color of the head with a function. So this is all stuff that you are supposed to, customize. This is not really part of the framework. This is more like an example within the framework. So the appearance, it depends on what your avatar look like. The animation manager, same thing. I have like a rather simple character like state here animator that has all the state because it can walk, this is first person, so it can strafe left and right and walk straight ahead or backward, and the rotation happens programmatically. I'm not gonna go into the animator and how to how to rig a character or how to control animate a character based on the movement. But one thing that I want to mention is that the avatar per se has an animation manager. The animation manager is actually pretty simple. It's just like a few lines of code. But the most important thing is that I want to be able to use this animation manager for all the avatars, even the other avatars. And from the other avatars, I'm just getting the position. So instead of sending information about the animation, I'm doing basically I'm checking what their movement is, what the previous position is, and what the current position is. So if the previous position was, behind the current position, it means that the character moved forward. And so I'm triggering the animation walk. And then there are like different types of, animations and things like that. I'm using a walk type. I'm using integer to send the animator that particular animation. Main thing, this is not, I don't even know if this is like a good practice or the best practice, but it kind of works and it's kind of like very simple, meaning that I don't have to care about what animations are being, like the animations are not sent from client to server and from server to client. It's not information. I'm just sending the position, I'm sending the coordinate, and the character reacts based on the coordinates and moves based on the coordinate, just for the sake of simplicity. First person controller is just normal stuff. Net manager I kind of like covered a little bit. Let me talk about the net.cs. So this is part of the framework, and it's really just it's a public static class, meaning that it is not a mono behavior. It is not something that is attached to any object. A public static class means that it will be visible from every script. So I have something called net, and if I reference something to net, I don't have to, this particular script knows what net is. Every script knows what net is because it's a static class. There are some limits to what you can do with a static class, but I'm basically using it to create a global object that is visible from everywhere. Some people might tell you that is bad programming to have global stuff happening, but I find it particularly useful, especially to keep track of the player, so I don't have to reference, cross-reference and send all like linkages to objects and even functions. So basically net is just a container of variables. I have a bunch of variables here. I've got a bunch of objects. I have a reference to the net manager, which is the core, the kind of like the main engine that runs the framework. I have a main variable that is the update rate, which is kind of important if you see that your project is like too if your updates are not good enough, like if it's too slow, if it's too laggy, you can try to increase this number. So that's the number of real-time updates that each client sends. You can also create different rate of update, because not everything needs to be updated, but continuously at the same speed. Obviously some events might be rather rare, and so you might want to send an update, but this is the update that relates to the transforms, to the position of the objects. And then you got a bunch of variables here. But speaking of objects, that's the main construct here, net object.cs. This is the whole idea around, like the whole framework is centered around this idea of a net object. A net object is a networked object. It has an ownership. That's how I managed to have to have smart clients that are managing, for example, the physics and the position of the object, but I avoid conflicts between clients, because one client might just happen, like some events in a client might happen a little bit delayed, and so you might have a problem with a different an object that is in different positions with different speed in different clients. So how do you deal with that? The easiest way, to me, the easiest way will be to use this system that I call distributed authority, because there is no client that has the ultimate say about every state of the game. The server is not authoritative. The server sort of like trusts the client, but the net object is owned by one of the client. There is a kind of ownership that happens, and so one client takes care of one object. For example, the avatars are owned by the particular client or particular user, essentially, that is related to that object, to that avatar. If a client creates a cube, like in the example, that cube will be tracked by that particular client that created it. The net manager takes care of changing ownership whenever it's requested or whenever a client disconnects. So if I'm creating a cube and I disconnect, the cube stays there, the ownership changes to another connected user. So you can just drop in and drop off, and it doesn't break the game, it doesn't break the structure, ideally, hopefully. If there is no client around, if I'm the last client living, all the networked object will be saved not only in the server, but also I created a kind of like a JSON file that works a little bit as a database. It will have probably some limits if there are a lot of them, but it essentially provides a very rudimentary form of persistence. So even if the server goes down or gets shut down, you can still reload those objects from the JSON file. And that's based on the type of net object that you have. So the net object here, you don't really need to know exactly what it works, how it works, but you can take a look at it as basically like interpolating between the current position and the position that is being sent to the server, and everything should be done automatically. Let's check how you actually created a net object. It's actually pretty straightforward here. It's this function here. So if you do net instantiate cube net persistent spawn pos, this is basically the instantiation function. It's the equivalent of the instantiate function in Unity, except instead of instantiating something in your client, you're instantiating an object that is being sent, kind of like sending a message to the server that sends down, broadcasts this message to all the clients, and so it tells every client to instantiate a cube to into their own, all the clients, and hopefully they will be, if all the clients are the same, it should be happening in the same position and so on. And since it's a net object, it will be tracked by net manager, and will be tracked by the server, and it will be kept on sync, or at least both clients and server will automatically try to keep these objects on sync. This is a system that I think Photon uses more or less, and Normcore, the newer framework plugin for Unity, also uses. There is a kind of like an ownership. The instantiation happens in a similar way as the avatar I said before. The avatar, in fact, is nothing but a net object, a temporary net object. So the instantiation happened by specifying the name of a prefab. The name of a prefab has to be in your resource folder. So I have something called ball, something called cube. If you create, a new prefab that is a car or something, you call it car, you put it in the resource, and you should be able to just like type car, and you're creating a car in there. But it has to be in the resource folders in order to link just by typing a name, an identifier. The second parameters of the instantiation is this type of instantiation. So it can be persistent, shared, and temporary. So the idea is that, by the way, most of the stuff that I'm talking about is listed here in the long README. So there are 4 types, actually like 5 types. So a temporary net object means that the ownership cannot be transferred and the object disappears when the player disconnects. So it's not shared. And this is what I'm using for the avatar, for example. You don't want to, like, you want your client to be in charge of your own avatar. You don't want to have other clients to be, in charge of your own, obviously. And when you're disconnecting, your avatar disappears and your avatar doesn't need to be tracked anymore. Private, meaning not invisible, but meaning private as in private property, meaning that the ownership cannot be transferred during the game, but it's automatically reassigned when the player disconnects. So the objects sort of like stick around when until they are destroyed specifically. Shared, it means that any client can request the object ownership. I believe those cubes are shared, meaning that you can grab that cube and another player can grab it and keeps track of it. And the object sticks around until it's destroyed or the server restarts. So the server, this is the server file, has also a similar data structure called game state. And the game state keeps track of the players, which are the web sockets, the sockets attached to it with their own IDs and stuff and positions and whatever. And it keeps track also of the objects that are networked objects, which include the avatars themselves, aka the objects that are representing the player, and they include those cubes or those balls that you are creating in the example. So the server is dumb in that it doesn't contain any game logic, but it always knows all the objects happening. It does have authority over who owns what, essentially. And then there is a kind of object, a type of object that is, I call it persistent, which is share. It's like share, but it persists even if the server restarts. And that's the JSON file I was talking about, this thing here. So the JSON file should be created automatically if you don't want to have any sort of persistence, because it can also create its own problem. You can just not mark any object as persistent. But it basically is a representation of the game state, especially the objects here that are, they have the owner, the prefab name, cube, or whatever, unique identifier, position, local scale, kind of like everything that you put, like there is some room for net variables that I might mention in a second. So this is kind of like the game state, and it's the number of cubes that are laying around and have been left there. And this stuff is saved in this, if not a real database, it's just a flat file. It's a JSON, which is a text file. So it's not a relational database. There will be a limit of the number of objects that you can have. You cannot have a persistent world, kind of like a Minecraft running on a JSON file. But it should be enough to keep track of a few objects that might be left around, and you don't want to just immediately disappear when everybody is disconnected. So that is kind of almost it, really. I mentioned net variables, so this is kind of like a feature that I tried. I don't know if it's like particularly useful, but I was a little bit concerned about you changing variables, and so there is a way to send variables without having to do like serialization and creating your own event handler. So say that you have like an event, you need in your game an event that is shooting or something, like you want to shoot a rocket or something. Well, it's not going to be super easy because you have to go to a controller, I guess. You want to create one of these net objects, but the net object probably might need some extra variables attached to it, and so the net variables is meant to be a bit of a framework for that. You can use that one object to, so let's see, net variable. Yeah, so you can basically use some helper functions such as set a variable or do something if the variable is being set, if the variable is being changed. You can look it up if you're interested. You can sort of like look at a couple of around like a couple of examples that are included here. But hopefully, yeah, here you have an example of creating a net variable and sending a net variable around. For example, the object changes color. So I'm changing something that is called example var. Although I don't know if I have the example var here in the net variables, but anyway. So all net variables will be here. Yeah, unique ID, and I guess you can have an example. Anyway, don't worry too much about that. I can give you some individual support. We can use that, expand that structure for different kind of usages. I'm trying to cover the majority of use cases, but obviously you can do any sort of things online. So there is a limit to the kind of flexibility that I can provide with this. So my struggle is essentially about figuring out a way to give you the maximum flexibility and let you, focus more on the game logic rather than the infrastructure of sending data back and forth, which is something that you have done with the previous assignment. So that's more or less it. Check the README. It should be all listed here. If something is unclear, just go and look at the code. Usually there is a comment there. It's a bit complex, but hopefully most of the complexity should be taken care of. All right, thanks.